Bismillahirrahmanirrahim. Assalamualaikum and good day. In this video, I'm going to demonstrate how we can compute the decomposition multiplicative seasonal model in Excel. Okay, first of all, multiplicative, you have to know that we multiply all the 4 components of the time series data. So first of all, we have to calculate the central moving average of the data to remove the seasonal component. Let's look at this example. We have quarterly data for 1, 2, 3, 4, 5 years. Okay, so first, in order to find the CMA, so since the data has seasonal quarterly, so we have to make the CMA by multiply the 2 times 4 order of moving average. So we average out the first 4 data. Okay, so this is average of the first 4, and then follow for the next data. So we average out the data one by one. So we're moving downward in one step. Okay, so the last one, we don't have this. So the last 2, we don't have this data. Okay, so the last one is this one. Okay, next is 2 times 4. So 2 times 4 means that we taking these 2 data, the average of these 2 data. So average is 2. Okay, so in the middle is 3. Okay, so it becomes centered. We check back. Remove this one. Okay, so this one. Okay, this one also we have the data. Okay, done. Okay, next step. So we know that when we compute the CMA, so we obtain only the trend and the cyclical, because when we take the CMA, we remove the seasonality and the error. So what left out is trend and cyclical only. Next step, you want to find the seasonal. So we divide the observed data or series by the CMA. So we cancel out these 2. So what left out is seasonal and the error terms. So now we taking this YT divided by the CMA. So we want to compute this YT divided by CMA. YT divided by the CMA. Okay, we start with the third data because we only have the CMA at the third data. Okay. Until the last data. So we don't have this last 2 data. Next step, we want to take average of each seasonal, and then when we take average, the error component will average out. So we know that the mean of the error will equal to 0, or we can say that the expected of the KUT here is equal to 0. So the mean of the error is equal to 0. So only left is the factor of seasonal. So since we have quarterly data, so we have quarter 1 until quarter 4, the seasonality. So we want to compute this for seasonal, the average. Okay, so we take can just simply take the average directly. For the first quarter of the first year, and then second, and then third. So only 3. Okay, the last one also we have the first quarter. So all 4 data. So this is the average of the first seasonality, which is the first quarter. Okay, we take all the first quarter data and then we take average. then followed by all the quarter data. We have to check back first, so second start from this second year, and then until, okay, so then we don't have the last second quarter, so we delete this, and then this one third quarter, we have the third quarter on the first year, third quarter, and then the last one we don't have, and until the last one, quarter 4. Okay, add up the first year, and then the last one we delete. 4. Okay, this one. Check back. All the 4 quarter is included in the average. Okay, next step, we have to calculate the seasonal adjusted series, which denoted by YTSA. For multiplicative model, the summation of the seasonal factor must equal to M, which is the seasonality in this example. So M equal to 4. So the summation must be equal to 4. So we have to check then, if it is not equal to 4, then we need to adjust it. Okay, so that's why we call it seasonal adjusted. So the final seasonal factor will be as J. Okay, so we compute this adjustment factor, or AF. Okay, we denote as delta, then we multiply by the initial of the seasonal. The data can be computed by using this formula, M, which is our example is 4, and then divided by the summation, so we get the delta, and then we multiply by each of the seasonality. So we sum up our seasonality here. Okay, so it is not equal to 1, so need to be adjusted. So I denote the adjustment factor as AF. So AF equal to 4 divided by the summation of the average. So this is what we need to multiply with this initial seasonality. So we multiply this with each of the seasonality. Okay, so we log this value. Okay, so we have adjust the seasonality, and then we check whether the summation is equal to the M, or in this case is 4, because our M is equal to the quarterly. So now it's okay already, it is equal to 4. So move to the next step. Then we need to compute the seasonally adjusted value. We denote as YTSA. So we divide the observed data or series by the ST that we have adjusted just now. So YSA. Okay, so the equation is YT divided by the ST. Then we need the ST here. Insert ST. So ST is this one. Okay, so we repeat this according for each year. Okay. Until the end of the data. Then we divide the YT, the observed value, with the seasonality. Okay, next step is after we get the YSA, then we have to estimate the trend line, okay, by using the YSA series. So this can be carried out by using the regression. Okay, so we regress this data by using data and then data analysis, and then we take the regression. Okay, where is the regression? Here. Okay, if your data analysis is not in your toolbar, so you need to find it or add it in the here add-ins. Okay, so option, and then you add in the toolpack. Go to option and then add-ins. Okay, add-ins. Okay, go. And then you add this one, analysis toolpack, and then click OK, and then it will be in your toolbar. Okay, so we select the regression. So input range. So we select this series, and then the X is the T. So T we select this one, T1 until T19. Okay, and then click OK. So this is the output of your regression. So here the coefficient here, the intercept is 455.21, and then the slope is negative 1.2. Once we get the equation of the regression, so we can compute the trend. Okay, write down the equation of the regression first, and then we compute the trend, okay, by using this equation. Okay, so this is the equation, beta naught minus beta 1 multiplied by the X. Okay, this is regression. So X now is the T. Okay, T starting from 1 until the 19. So this is trend. Okay, T trend. Okay, after we obtain the trend, we can examine whether the series has the cyclical component or not. So we divide the CMA by the trend that we obtained. Now only left out is the cyclical. So CMA divided by T. So T is CMA. CMA is with this one. CMA divided by trend. Okay, now we see that the value of CT, which is the cyclical, is nearly 1. All the value here, we can see that nearly 1. So we can assume that there is no cyclical component in the series. So once we complete this, so means that we have separated the YT into the component of seasonal, trend, and the cyclical. And then we can measure the fitted value by compute the 3 component that we have just seen just now. So trend multiplied by seasonality and the cyclical. So here is YT head or the fitted. So fitted equal to the seasonality multiplied by the trend multiplied by the cyclical. All the 3 components. Okay. So then we can check with the error. Okay, I hide these 3 columns first. So this one, the error is the observed minus the fitted. So then we can compute the error. This is the error or fitted error. And also we can forecast by using the decomposition method, the trend and then trend equation, which is this one. Okay, just now we multiply this by the T from 1 until the 19, right? So we can substitute into 20 because our next data that we don't have the observed value is the 20 data. So then we multiply by the seasonal factor and also the cyclical component. So let's try to forecast. Just now is the fitted, right? Okay, the last data that we have is the 90. So this next data is 20. Hide the data of this row first. So then you can see. Okay, forecast 20th data equal to the YT. So trend, where is we put here 20 first. Maybe we want to forecast until 21. Okay, so the trend, okay, means that we multiply by 20 and then 21. Okay, so then we compute for this forecast trend multiply by the seasonality. So we have to careful here. It is on the quarter 4. So we have to choose the 4th quarter of the seasonality. Okay, so this is the value of the seasonality of the 4th quarter. And then we multiply with the cyclical component. In this case, we don't have the cyclical component. So only left trend and seasonality. Okay, so the next forecast is 20th, 21st data, and then it is on the first quarter, right? So we take the seasonality of the first quarter. Okay, so this one, first and second quarter that we want to forecast. So this one should be taking the expected quarter value. Sorry, not quarter 1, quarter 4, and then quarter 1. Okay, so this is quarter 4, taking the seasonality of the quarter 4 and then multiply by the trend. Okay, this one is equal to 0 because it's multiplied by this cyclical, which is we don't have the value. So we delete the cyclical. Okay, should be just now I delete this because we assume that there is no cyclical component, right? So I delete the cyclical. Okay, so this is the error. So you can compute this error to see whether the forecast, the fitted is okay or not. And then also the forecast here, because I didn't divide the data into training and testing, so we cannot find the error of the forecast here. So first you need to divide the data first, so then we can see whether the forecast is okay or not. Okay, that's it for multiplicative decomposition model. So I hope that you can try on the additive model. So there is step by step also in this note, so I hope that you can try on. Okay, that's it. All the best. Bye. Assalamualaikum.